Good evening, welcome. Uh, Tonight's topic, as you can see over here, is actually something of a hero of mine. He and I have something very much in common. Over, how's that? Okay. Uh, in his case, well over 200 years before I encountered the problem too. Uh, Neither he nor I, at one point in our lives, could not afford a commercially made telescope. So both of us ended up learning how to do that. Except I could have used his help really. Um, but that led me to a career in optics, and this guy's probably at least a good part of it, being responsible for me getting into it, and for that matter, staying with astronomy. So we're going to discuss his life and times and what he did and the legacy he has left us. Okay. Okay.
Just thought you might need this.
Actually, I'm gonna.
You're gonna be okay with that?
Oh yeah.
Okay.
Thank you, though. Yes, I know. Okay. So in the late 18th, early 19th century, science of astronomy took a major leap forward. A one-time musician became the world's greatest visual observer and instrument builder of his day. It's William Herschel. Born Friedrich Wilhelm Herschel in Hanover, Germany, he was the eldest of 7 children. His aptitude for music became apparent very early in life. And at age 14, he and his younger brother, Alexander, imagine how young that had to be, about 12, were inducted into the Hanoverian Guard as army musicians, which is actually quite a bit of a responsibility because the way that they communicated, they didn't have walkie-talkies, they didn't have radio and such. They would play certain music, and that would say, go off to this direction, go off there, charge, retreat. And they had to get this down pat. After the disastrous battle at Hastenbeck, the two brothers were honorably discharged from the Hanoverian Guard. It was during this time his musical career became fascinated with the sky. I'm trying to track that down, and I can't find the exact match for the interest and with music, but they are kind of interrelated. There had been a rumor in the 1970s, early 80s, that William Herschel abandoned his post. It was an AWOL. Well, it turns out that they found other records that show first off, he had never taken the oath to serve king and country. And more importantly, it turned out that he was too young. Both he and his brother were too young to enlist or be enlisted into their army at that time. That would change, unfortunately, as history went by. Okay. After all this, he settled in Bath, England. This is Observatory House number 1, if you will. This is where he lived. And this was the backyard, which is where.
Somebody online is not on mute.
Yeah. Could everyone please make sure you're muted out there in the wide world? Thank you. Okay. So this is where he stayed in Bath, England. Still stands. What's that?
Hold it up.
Oh, I get paid for this. Anyhow, this is where he stayed in Bath, England. This is the backyard where he did his first observations and such. And this is the workshop and a foundry that still exists. This building and all this have been pretty much preserved. They have restored the garden. And there's a statue, I think there's maybe a picture of it later on in the talk, that they have a shot of William and Caroline, his kid sister, who worked very closely together here and other observing sites. We'll get to those later. Okay. Escape to England. I can almost hear the Indiana Jones music at this point. Herschel's sister Caroline was able to follow her brothers to England and escape her mother's dictatorial attitudes. Caroline had a very hard childhood. At age 3, she contracted smallpox and typhus about 2 years later. We believe that's what stunted her growth. We have one of her dresses which showed that if she was 4'5", it was a lot. However, she had a beautiful singing voice. And, well, let's put it this way. She met, after the brothers went to England, she was able to get away from mom, who was convincing her to stay there as an unpaid servant. Lovely, huh? Okay, she would keep her brother's notes, though, when she went to England, and assist him in instrument building and observation. Also discover on her own a total of 8 comets. It was the first time that a woman put eye to eyepiece and discovered these wanderers in the outer solar system. And for that, she was rewarded a gold medal by the Royal Society. Back then, that was unheard of. But everybody was, well, I'll say it like it is. They were charmed by her. They saw her brilliance and her capabilities of observation and such. So she got the gold medal. Okay. Now, before we go into Herschel's big telescopes, we have to talk about telescopes in general. Most people here are probably familiar with the Newtonian telescope, named for Isaac Newton, as a parabolic primary and a secondary mirror, which is flat, that directs the image to an eyepiece on the outside of the tube. However, the materials they were working with weren't the best in the world, reflectivity speaking. Our mirrors today are coated, unless you have very specialized ones, they're coated with aluminum. Each reflection loses about 8 or 9%, especially with a fresh coating. In the case of speculum metal, which was the only material that they had, chemical silvering didn't come for about almost a century after this work come through. So you had to polish this metal. It was high tin copper alloy, which meant, especially in England, which had wonderful fogs and some air pollution, they would tarnish rather quickly. So each mirror on the average would reflect only about 60% of the light that would hit it. So here you would have, say, a 10-inch telescope in a Newtonian would only have the light gathering power of about maybe a 3.5-inch refractor. Yeah, you get resolution, but it's a dimmer image. So he said, okay, let's make this primary mirror a longer focal length than normal would be. And let's not even use a secondary mirror. Tilt it so that it's out here and you're looking down the tube for the most part. This is why it's called a Herschelian, because he came up with this design. So you may have lost about 35% of the light, but you still have the resolution of this big instrument with a nice, reasonable design. And he had made quite a number of these. Okay. And this is the observing notes for Saturday, the 17th of March, 1781, at about 11 hours. I looked for the comet or nebulous star and found that it is a comet, for it had changed its place. Well, it's a very slow comet. This is what it turned out. Others picked up the chase. They looked at it, and after a little bit of quick mathematics, they found out that this was a comet in an almost circular orbit around the sun with an 84-year year. So this was not a comet, because as it seemed to approach the sun, it did not develop a tail, didn't get nebulous. So they realized, hey, this is another planet. He worked with other instruments too. First, before I go on to this, the telescope that he used to discover Uranus, as it was later named, unfortunately, we don't know which one it is. There are several in various museums, and everybody's claiming that was the telescope he used. Oh, well, who knows? Maybe one of them was. Okay. He decided to go for more light. Now, you still are losing about 30%, 35% the light that's coming in the telescope. But imagine a 20 feet focal length instrument like this with an 18.5-inch mirror. So you're still going to get, in modern terms, a fully reflective telescope as far as reflectivity is concerned, with a modern aluminum coating of about a 14, which ain't bad. And you see, this is not an equatorial one that tracks the sky by moving in one axis. But he had pulleys, you can see up here, and hand controls by the telescope, by the eyepiece. And you also had a workman or two that would help swing this in just to get a position, an azimuth. The altitude part was pulled up by the system of pulleys, and then you have fine adjustments up there. This is one of his favorite instruments, the 20 feet, which had an 18.5-inch clear aperture mirror. Eventually, it turned out that he needed a little bit more room than what was in that, so he moved to this. This is called, nicknamed Observatory House in Datchet, which is relatively close to London. And it was there he was able to build this. This is the 40-foot telescope. It had a 48-inch mirror. There are he cast 3 of them. 2 I know of. 1 I think may still be in cold storage somewhere in a museum. But this instrument, again, it's out azimuth mounted. You can see he had a small house over here, which is where 2 of his workmen, his hired hands, would stay to keep warm, at least stay away from the mirror, of course. But this is the largest instrument that he had made, and you can see this is Herschelian, because there's where the eyepiece is. Not like Newton on the side. It's all right here, and there's Herschel, and very stylized over here, because Caroline was a lot smarter than staying here, because quite frankly, it was darn cold in my observatory house. So he would call out to her, and she'd have an open window, which had a nice roaring fire in the fireplace. And took no, she was not bad. She knew what she was doing. And also probably one of the best record keepers he could have had. Okay, this is what's left of the 40-foot today. Most of the tube is gone, and only a small part of the mount remains down here. The tracks that would move back and forth on. But there it is. This instrument, if you will, had even more starlight than any telescope up to its time.
Well, that's not usable because it's too short to get a focus on the focal length.
Oh, certainly. And the mirror, there is no mirror in this. It's just reserved
Okay.
back cube of the Royal Observatory. And you can walk around it. You can imagine Caroline calling from the house, not this one. Calling from the house. Okay, so what are you seeing? And he would tell her. I don't know what happened to the rest of it. I heard something about the possibility that a tree fell down long after he passed away. Well, the instrument was just sitting there for some time. At least that's what I've heard. I'm not quite sure how true that is. Okay. And he was quite a prolific optician. He did a lot of experimentation in different designs, methods of polishing alloys and such to get better reflectivity. But best of all, it would have been silver. And that's in fresh silver is about 97% reflectivity in white light. Unfortunately, as you know, silver has a tendency to tarnish. And if you've got lots of coal fires around, as was true around London, Datchet, and many other areas now, it would tarnish rather quickly. And try as he might, he could not protect it. So he used somewhat higher tin, if I remember correctly, alloy. It wouldn't tarnish as quickly, but he was doing lots of experiments, trying to see the proper alloys, methods of polishing, faster, slower. When the time came in the 1950s to raise Observatory House to redevelop the grounds, hundreds of mirrors were found all over the place, behind the walls, in the attic, in closets, the back of closets. It was crazy, but it was all there, and I sure as heck hope somebody had taken them to at least a museum to at least preserve them. I don't know where every single one went. Love to get my hands on one of them, I'll tell you. Okay, and here you go. His son, John, in 1839, took this photograph. That's his father's 40-foot reflector. His father had been gone for about 17 years at that time, and it was getting more and more rickety. He almost never used this instrument, John. But this is the first positive image on glass plate photograph that's ever been taken. John Herschel himself specialized more in photographic work, what we call snapshot at one time, negative, positive. You set a point of sodium hypochlorite, which would preserve the image. He called it hypo. There are a lot of terms that we use when we were doing chemistry, and even now, if you are still a purist and you want to use film for your work, and if it's black and white especially, he actually came up with most of that chemistry. Okay. Herschel experimented in optics. You would imagine that if someone's going to be polishing optics and working with them, he would do this. He decided to see if colors had corresponding temperatures. I really don't know where he got that idea, but we benefited from it. Herschel found that the further to the red end of the spectrum, the greater its temperature. He then moved the thermometer past the red end to calibrate it on the temperature of the room, and the reading increased with no visible light seen. He had discovered what we today call the presence of the infrared light, or heat energy. That'll come in real handy. And then in the 1990s, using the University of Hawaii 2.2 meter telescope, this is the planet, its weather patterns, the ring system, and several moons here imaged in the infrared all at the same time, with the near infrared multiple object spectrograph camera, or NICMOS for short. And, everything in one shot. That's amazing. And you can see in the atmosphere itself, there's some there's a hot spot. You gotta remember the temperature out in these parts is about minus 370 degrees below zero on average Fahrenheit. So the instrument itself, the NICMOS camera, it's going to sound like I'm bragging, but I'm not. We got a contract when I was working at Optics and Research to make some exotic materials into optics. A window about that thick, which was made out of calcium fluoride, or fluorite, if you're an entomologist. The other lens systems were barium fluoride, barium fluoride, calcium fluoride, and zinc selenide. All of these transmit the infrared of one sort or another, and we have filters in front of. Well, we made these things. If I wondered why I was going gray before I started going bald, I know why now. Because I think back on that, we were going nuts with this. So we finally got everything polished, everything done, everything was to spec. We sent it out, and they even sent a special courier to carry these out. They put them into the 2.2 meter telescope in Hawaii, University of Hawaii. And everything was great, and I felt pretty good about it. So I don't know, that maybe, what was it, about 2 or 3 weeks, something like that. Later, I come in, and I just walked in the shop, saying hi to everybody. Still got my coat on, still got my briefcase with me. And my supervisor, John, comes in and he says, "Oh, good, you're here. Come with me, quick. You don't do that with me." I'm saying, "What the?" Among other things, "What's going on here?" He said, "We got an emergency." Go upstairs, I figured maybe something broken off it. Well, it was sort of close. As I mentioned, they had a window about 1 inch thick and 3.5 inches in diameter on the front end of this instrument, and the other lenses behind it, which did the focusing imaging. Well, what happened was I spoke to one of the researchers. It was from University of Japan, Kyoto, and he was saying, "Okay, you're the optician that did this work." And I said, "Oh crap, what happened? Did it blow up in our face or something? It's not figured right." No, not at all. One of our grad students was told to set the camera up back. It was on the Friday before. This is on a Monday, and he was told how to do this. Well, he was supposed to be told that you put in first. You turn on the electric coolers. They bring it down to about minus 70 Fahrenheit. Then you slowly pour in liquid nitrogen, which brings it down further, almost 300 below. Finally, you bring it down to just above absolute zero with liquid helium. The kid didn't pre-chill the outlet, and the liquid nitrogen made it blow up like a small stick of dynamite. Well, I hear this and I say, "What's his name and where does he live?" So I'm no joking around. I put a lot of work into this. And he said, "Well, luckily, he only cooled down the front of the system, which was the calcium fluoride window. Again, it's about 3.5 inches thick, but about an inch thick, a little more." And I said, "Okay, do we have any calcium fluoride in the shop? I know we got a couple blanks." And we took it from another job. And I said, "Okay, where is it in the grinding area?" I found out that it was already, when we got this call, the call actually in our time was about 6 a.m. So like fully an hour and a half before anybody would want to show up. And to make a long story short, we had to replace that front window and we had to do it fast. So I said, "Okay, this is what we're doing. I'm going to stop everything else." Because normally I had like five, maybe 6 machines going at a time. I'm going to concentrate completely on this thing here. And if I go out for lunch, I'm taking it off. And my supervisor, John, says, "Well, I'll keep an eye on it." And I said, "Okay, but remember, it's your eye, not mine." Well, we got that thing out ground. Magali was one of our clients, one of the better people that could get power loads and the flatness. And she popped that thing out faster than I've ever seen anyone work with soft material. You could scratch this stuff with your fingernail easily. But she got it out and blocked it up, and you had to heat it up slowly, put pitch on it, take the warms back, put it on there, and let the whole mess cool for the next 4 hours to get down to room temperature. Remember, this thing's thick, so that means it holds its heat very well, thank you. So we spent most of the first day on this, just waiting for it to cool down. Next day, I come in, we touch it out, we clean it up, grinding it. Got it reasonably flat, got the lap on. Luckily, I kept that lap, magic lap, as I call it. We polished the one side, and then we said, "Okay, you're going to get a taste of cold." We had a small refrigerator that we put that optic into, and a lot of paper and a lot of prayer. The pitch let go perfectly. I had to wait the rest of the day for it to warm up. I was not about to just put it out in the open or even try putting it near, not on, stove. So we let it sit. Painted the other side of the first side with a special kind of protectant. Then next day it was at room temperature. We brought it up nice and quietly. We put big fat button of pitch on top of it, about an 8-inch thick. Let the whole assembly cool down when we had a backer on with aluminum, which had the holes that you would put to correct rather parallels in the footprint out, which did not make sense. Make a long story short, we did the first side in 2 days, and the second side of that day and a half is still don't know how to make it faster than 3 days. By Thursday, we shipped it out FedEx special delivery. I mean, I think of a teleporter if they would have done it. They put it in the equipment and started it up and cooled it down, and it worked perfectly. We got lucky. They got lucky. But the Hawaii instrument used that optic to get this photo, and the other optics in there too. I'm not bragging about it. If you wonder why my friends here, why my hair went gray first, that's the reason why. Because I was working on it, but it came out really, really nice, as you can see. Years later, at the that was at the Northeast Astronomy Forum, I got to meet Dr. Heidi Hamill, and she talked about this instrument and talked about photography. And I walked over to her and I said, "So how do you like your Nick Ross camera?" "Oh, it's incredible." I said, "I'm the optician that made the optics." And she said, "OFR, optics for research?" "Yeah." "Oh gosh, Don Wilson told me you must have gotten that thing out in like 3 days." And said a little more, but yeah. "Oh, that is a powerful piece of equipment. that shows. To me, that was reward. So. Okay, now what he saw up a close up, getting back on Bill Herschel here. Image by Voyager 2, the battered moon of Saturn here, Mimas, showed what Herschel could not have guessed was there. He had discovered it. And this is this wonderful crater. Remember, since it was 45 miles across and roughly about a mile or more deep. It shows that it's solid. There's no ocean underneath it. Otherwise, we would have seen the splash product. We didn't. He also discovered Enceladus that appears to have a subsurface ocean. And he discovered 2 moons of the planet he discovered, Titania and Oberon. I wish I had that picture. Okay. Using his instruments, the 20 feet and the 40 feet, he speculated that the structure of the Milky Way galaxy could be seen in his large telescopes. Here he had a strong sense of illusion because to one side, if you look toward Sagittarius, there's quite a few stars here. You look the other side, heading toward Virgo, and it's not quite as much. It's not a bad rendition for a first try, but this is where it kind of fell apart because he was saying there was a structure, almost like a scaffolding of the universe, and this is how we even see it wrapping around us. This is what he thought it looked like. There's even a little spur over here, which corresponds to Sagittarius. Okay, modern recognition of the Institute of Physics over in Great Britain. Here lived the scientist and musician Sir William Herschel, 1738 to 1822, from where he found the planet Uranus, March 13th. Note the date, 1781. He also discovered infrared radiation in 1800, and his sister, Caroline Herschel, was an early woman scientist, darn straight. 1750 to 1848. She died at age 98. For a woman who started as a baby that first contracted typhus and like a year, 2 years later contracted smallpox, she lived quite a long time. And she was a hunter of comets. Okay. Now, I looked at this off the web. I think it's wonderfully done because it does quote some places it's exact quotes, some they're filling in the blanks and such. I love this here. Yeah, until she was 22, was a mother's unpaid servant. My father told me as I had neither beauty nor riches. As smallpox victims go, she didn't have very much for her. No man would be likely to make me an offer until I was old. Someone like on my account of my worth would marry. Never married. 1772, she moved to Bath to join William. He planned to train me as a singer, but he was distracted by his growing interest in astronomy. Music career ended in 1781 when William discovered a new planet, Uranus. He made King's astronomer, not astronomer royal, but King's astronomer. The year after we had moved to Berkshire. I found I was to be trained as an assistant astronomer, which was to sweep for comets, and began on the 22nd of August, 1782, to write down all remarkable appearances I saw in my sweeps. Basically, it's an out-azimuth telescope, so it just swung 10 degrees and come down half a field of view and come back. Fast forward, I began to discover a comet, actually. 1783, she had already discovered New Nebulae with her own telescope. But the main job was to assist William. And it could be dangerous. There were chains and hooks all over this 40 feet. And she got caught in the leg. It's terrible. She was lucky she didn't. From that, she didn't. The only thing that may have saved her was, quite frankly, it was heavy snow. And the cold may have staunched the bleeding on that. She found her first comet in 1786, the first that was ever discovered by a woman. And she would add 6 more. She was granted a salary in 1787, granted a salary of 50 pounds per year by George III, making her the first ever professional female astronomer. And William passed away in 1828. She returned to Hanover, which stopped observing, but she continued to work on her observations she already had. The Royal Astronomical Society awarded Their great medal to her in 1828 in recognition of her catalogs. Became an honorary member of the society in 1835, one of only 2 women. Fantastic. She passed away at age 97. Not bad for a kid that was very sick. But the obituary said her memory will live on its own merits. And the Herschel Space Telescope, launched in 2009, carries on the Herschel name. It has just begun at that time when this was written, just begun its study of the universe. No building. Okay, and continuing the legacy, his son John and his family went to South Africa and Cape Town to extend his father's catalog of deep sky objects, he called the general catalog, into the southern hemisphere. At Feldhausen, or Fieldhouse, John used the 20-feet reflector. He liked the scope too. Everybody said it was easy to be able to maneuver and work. This marker, which is on private land now, recalls the work that John performed over 3 years. I think they got to clean this thing up. So, it's just sitting there and it's terrible. But that's just me. There's John over to the southern right here. Okay, so on display, yes, you can go to the Royal Observatory in Herschel. This is the only piece remaining. It shows part of the structure that this moved back and forth on the rail, and it actually pivoted up and down from that point. And this is one of only 3 mirrors that survived. And it's tarnished, as you can see, but it's still there and still preserved. I think there are 3 of them. This is one of 2 that are on display. There we are. Now, in the modern era, this is actually one of his telescopes in beautiful condition, cleaned up and such. It was a 6 1/4 inch mirror in here. This is a modern Dobsonian, and actually it's a straight line from the Alpazin Mount right to here. I believe that's one of the mirrors that was set up. Now itself in 2009, 2 amateurs built from plans that were given out by the Herschel Society and built these instruments. They are wood for the most part. Nice picture of Herschel over here. And it's not speculum metal. They had to cheat it. They didn't know how to polish it. So it's got an aluminized mirror. Herschel would have killed, gained 25%. However, they did a beautiful job on this, and I think it took a first award. He and his friend took a first award for maybe mechanical. Okay, and there are more honors that are coming in recent years. You're looking at the 3.5 meter mirror being processed for this telescope, which is the William Herschel telescope. This is on Tenerife, near Canary Islands. Talk about working optics. The biggest optic I made professionally, honestly, was about 20 inches. And even that was a pain. That was a flat, for heaven's sake. This had to have a precision curve. Okay, and this, of course, is the Herschel Space Telescope. This instrument works a little further into the infrared than William was able to get to. This is in microwave, which is a shorter version of infrared, you guessed it. 3.5 meters in diameter. About 3.5 meters, that's about as long as one of his 8-inch telescopes in length. It was shielded. This is still on solar orbit right now, and I hope to God they don't decide to turn this off. It's doing a lot of good work. This bridges the gap between light and radio in observation. Okay, there we are. Herschel at Stellafane. There we are. I mentioned that before. This is out of sequence too. Okay, well, these are 2 replicas. I would love to be able to do something similar to this with modern optics, of course. Okay, now in his own words, the story behind this basically is simple. There were some young people, young astronomers just getting started in their career, And here, Herschel was, well, actually, it's not 1822, it's closer to 1819. I apologize, I just realized that's when he passed away. But he's listening to these young people out of nowhere. He says this. What he was doing was not boasting. He was challenging. This is what I did. You do better. So, for further reading, I recommend both of these books. You're not going to find this too easily. You have to do a book search. I had to. Oh God, back in 1964, just after the last Mastodon died, I saw this put out by Scholastic Book Series, and it was Pioneer Stars by Nathan Sullivan. You can still find it, and yes, it's written for young people, but it's nicely done. It fills in gaps here and there, or saying that Galileo said, try to have them prove you wrong and all that, for example. But the part on Herschel where he built his own telescopes inspired me to try doing it myself. Here I am at 10 years old. Not a lick of information at all on how to make optics, but I stayed with it. And then this book here, this is the book. This is the cover of a Dover reprint. I recommend it very highly. Goes up to 1955 when it was first released. I have a first edition of it, which I take out once a year. But this is a terrific book. It is the history of the telescope. Henry King did an incredible job on this book. This is a fun book. This is Deadly Series. I recommend both. You can find them in the book search for Pioneer Astronomers. Jump on it. You can find it. Don't think so publishes this. So I think when I picked up my other copy, I have a first edition which stays in the house under lock and key with a very vicious bulldog. Be careful. But I also have the Dover reprint. I recommend it very, very well. You find out a lot of the stuff, and there's even one section in there dealing with the 100-inch. You see that Hubble may not have really come up with the Hubble constant. He had a lot of help that he plagiarized. Yeah. It's actually in there. Okay, and I have to thank various people here. Bonnie, of course, my wife over there, who has put up with me putting up telescopes all through our marriage and before it, actually. Mary Duca, Sam Mello, who's not with us anymore. He's the guy that if you go in the 10-inch refractor, you can see that Miller scope, if you will, because he put so much work into it and did a beautiful job on it. Tony and Esther Payon, both are gone now, of course. He was past president and trustee of the organization. I was a wet behind the ears kid in 1980 when I took the presidency here, and he offered to bridge the gap between the college and other places for me, and I was going to use them very well. Unfortunately, they died together in a car crash. So, but at least he did it with someone. He died with someone he loved, and in a car that he loved, Aston Martin. So, I also have to thank next young lady here, Leah Leocadia, actually, Coronado of Escal Optics. And she and I conspired to get a lot of these optics out. And, I knew the theory, she knew a lot of practicality, very good, very dear friend. Of course, this place, Amateur Astronomers, and the Springfield Telescope Makers, or Stella Fame, there they run every year. It's a privilege and an honor to be up there. Really fantastic. And I believe that's the last of our slides here. There it is. Okay, and good evening. Thank you. Okay, are there any questions from the audience here? Everyone's completely stunned. Yeah, I see a hand. Yeah.
No, a silly question, but I noticed that you described the telescope primarily in terms of length rather than aperture. And today when we talk about it, you know, the 8 meters past the 10 meters, talking about aperture. When did it change?
That's my question. Probably around the 1840s, because they started working with refractors on a wholesale scale, and then it really got too big. So we were more interested in aperture, how big the light gatherer it is, so rather than how big the tube is. And sometimes I wondered what happened to Caroline tripped over a hook that came down in the snow, and she tripped on it and caught it right in the leg. I think I'd probably redesign that thing too. Any other questions?
I got a question, Al.
Okay, I was just about to ask if anybody online wanted to ask. Go ahead, Cliff.
The telescope that was exhibited at Stellafane that had the very nice model of the kind of mounting that Herschel used, why did they make it a Newtonian? That would have been interesting to show the tilted optics that Herschel actually used.
I never got a straight answer on that. I even said that, you're supposed to be using a Herschelian, you're supposed to be looking in the top of the tube. The guy said he just wanted to have a Newtonian.
Okay.
Oh,
Yeah, it's easier to make too.
yeah, that too.
The story goes that Herschel used a simple lens eyepiece that he tilted slightly, and that corrected the astigmatism resulting from tilting the primary mirror.
That sounds about right. Yeah, I didn't even touch on eyepieces. As short as to make his eyepieces, they were all single lenses, not like today. What they ended up doing was making a bead of glass and then cutting it or grinding off, so he ended up with a plano convex lens. And that's what he worked with. I know that they did find some years ago a number of his eyepieces. One of them would have given on even the 6-inch telescopes, would have given a magnification of well over 400. Empty magnification, I dare say. The field of view was only about maybe 3 minutes of arc. You just about be able to fit Jupiter in. So, any other questions online? Okay. How about out here? Any questions? I'm dazzled everybody.
It's not really a question, but I would be scared to death to use those things where you have to hang in this little wooden basket. Oh, no way.
Well, actually, it was pretty sturdy.
I'm sure it
But,
didn't look
yeah.
sturdy enough for me.
Yeah, not me either.
The scalpel.
Ladder. You can see that ladder.
Yeah, that's
Yeah.
right. And they switched over, and he had 2 workmen, 2 with 40 feet.
There was no ocean.
So, yeah, thank God. Yeah, thank God, right, because to clean the speculum metal, sometimes when they're melting it, they throw arsenic in.
Oh,
Yeah, nasty stuff. That's what we had workmen for. Higher help. Any other, yeah, exactly. Anyone else?
Yeah, Al, I have a question that's not related to your speech. It's just a matter of, has anybody heard of the Starfront observatories out in Texas? Where you can rent like scopes that they have in a dark site area?
I think I've heard of it. I haven't run it to ground yet.
Oh, I was just curious because apparently you can, I saw it on the news and this guy showed his telescopes. He wasn't even using them anymore because he just rents time on the scopes at Starfront observatories. Which, it's in a dark area in rural Texas. And
Whoa.
apparently you can do all your imaging from that place.
Fantastic.
Something for people to keep in mind.
No, I saw a picture of that.
Oh,
They have a lot of storage sheds. And the roofs come off several of all the storage sheds, which all have telescopes in them.
They got a ton load of scopes there.
pretty good.
Yeah,
Okay.
look it up. Anybody who's into imaging might want to think of that.
Darn straight.
Yeah.
great job, Al.
Thank you. We tried. Okay, well then I'll end it here. I thank all of you for your attention and do what Herschel always advised. Go out and observe, see for yourself. You need